Welcome friends, as we are talking of optimization of revenue or maximization of revenue, whenever we have a situation of capacity constraint, wherever the supplies are limited, and we have discussed that there are different types of issues when you have limited supply and that supply is also perishable at a particular time. You may remember that we discussed the concept of run out price, which is generally the higher than the optimal price which is applicable in case of unconstrained supply situations. And we also discussed the concept of marginal opportunity cost which is applicable that whenever you have the limited capacity, your marginal opportunity cost starts increasing. So, as you continuously reduce your capacity, your marginal opportunity cost decreases. So, one simple answer is that we need to have more and more capacity, so that our marginal opportunity cost is lower, and at the same time you will be having higher revenue as per the available capacity. But we all know that it may not be in our hand to decide the capacity. There are resource requirements for having the capacity, and if you do not have those resources, maybe the capital is one such resource. If you do not have enough capital, you will be running short of the required capacity, and then you have to see that how you can maximize the possible revenue from that available capacity. And we have discussed some kind of strategies like the differentiation of the customer categories, and for different customer categories you may charge different price, and ultimately with the objective of maximization of revenue. You may recall that how we discussed the example of one stadium where you thought of two categories of customers. One is the students of the university and then general public. So, that is the way we have decided some number of seats for group A customers and some number of seats for group B customers. Similarly, in the airlines also we do this kind of classes, and for a particular class we can keep a particular label of price. You may recall that we discussed about tactical labels of pricing, and we discussed that deciding all these different classes which we will have and the quota for each class, that is the role of tactical. And then comes the role of booking control, where you have to take a decision with respect to available capacity. If you have a capacity and a request is coming, you will accept, otherwise you are going to reject. So, in this particular session we are further going to discuss the implementation of the concept of booking control. We already introduced the another important concept which we are discussing in this particular session, that is the concept of nesting. We discussed that how it is possible there are some drawbacks of booking control. So, with the concept of nesting we are trying to overcome those limitations. So, with some numerical examples in this particular session we will see the concept of booking control and nesting. So, we will be talking in detail about booking control, allotment, in detail about the concept of nesting, and then dynamic nesting booking control. That is the most important contribution of this particular session which we will be handling. And then also there may be cancellations. There are bookings happening, but at the same time cancellations may also happen, and cancellation may happen in different categories, different classes. So, how are we going to handle those cancellations? Whenever a cancellation is happening, how to add this new availability into a particular category, that is to be seen. Now, as we already discussed in our earlier classes, that the concept of booking control is the real time phase, the online kind of a phase of this concept of revenue management. Here we are going to decide about accepting or rejecting a particular booking request based on the criteria set at the tactical level. Whenever a booking request is received, you will give a yes or no based on the capacity which is available for that particular class. Let us see with the help of some kind of data which we have discussed also, but just to have the context for this particular session, I am repeating the same example which we have discussed in our earlier class also, that for a B class we have a request coming for 3 seats. There are different classes, let us say A, B, C. These are the 3 different classes in a particular flight. Let us say BM 509 is the flight number, and in that flight we have A, B, C. Now, you are getting a request of 3 seat, available capacity is 2, decision will be reject the request, because your available capacity is less than the requirement which is coming. Similarly, a request for 3 seats in C category is coming, the available capacity is 4, you is going to accept this booking. So, this is how in real time you are going to do. Then the available capacity now in C is 1 seat, and another request in C category is coming for 2 seats. Since now the available capacity is less than the request, you are going to reject. So, all these things are happening in the real environment based on how things are processing and how much is the available capacity you have. Allotment is another term which we discussed in one of our earlier videos, where to manage bookings we have to divide the available capacity into the discrete classes, and for each class we are having a particular fare. Like in this example, these are the classes A, B, C, these are the 3 different classes. If I go with this example of flight 137, we see that we are going to have these 3 classes, B class, M class and Y class. B is the economy class, you can say, M is a kind of a business class or executive class, and this is the business class. Here for each class you are assigning a particular fare level, and how much you are assigning to a particular fare level is known as allotment, or in our simple terms we can say that quota given to a particular fare level is allotment. While the allotment approaches is very easy to understand, it has a major drawback that we are going to discuss. It does not work very well. In particular, it can result in a high fare customer being rejected, while a lower fare customer are still being accepted. As you can see in this particular example, now I have 3 fare categories 125, 200 and 560. I have divided their capacity into 3 categories like 30, 45 and 25 respectively. This is the total. Now, on a particular day I checked, as you can read on this slide, that about 2 weeks before the actual departure of this particular flight, we saw that 25 seats are booked in B class, 45 seats are booked in M class and 10 seats are booked in Y class, and these are the remaining seats. So, you can easily understand. Now, today if I go for asking a ticket for M class, I will be rejected. This request will not be accepted. While it will be funny thing that you may get a ticket at the lower fare class, which is 5. So, which is B class. So, 5 seats are available here, but no seat is available for a higher fare class. So, which is looking slightly disturbing. It is not natural justice that you are still ready to give tickets to those who are asking for lower fare class, and you are rejecting the request of those who are coming for the higher fare class. So, that is a limitation of this approach of allotment. So, therefore, a concept which is known as nesting, we already discussed very briefly in one of the earlier video about the concept of nesting. Now, this concept is basically developed to avoid the rejection of high fare booking in favor of a low fare booking. Wherever possible, you should always accept. The natural thing looks that first you should close the booking of B class, then you should close the booking of M class, and then you should close the booking of Y class. If, for example, it becomes even more funny that you are not giving Y class seats, but still you are giving B and M class seats. So, therefore, this concept of nesting says that it is a situation which can be avoided, that you are rejecting the high fare customers and you are accepting the low fare customers. So, each time every fare class has access to all of the inventory available to lower fare classes. So, if I am coming for Y class, the available inventory for B and M class is also available to me. If I am coming for M class, inventory available for M and B class is also available to me, and obviously B class is the lowest fare class. So, all the if I am coming only for B class, so the inventory available for B class only will be available to me. So, this concept is stated in the form of mathematical inequality like this, that you are numbering the fare classes so that 1 is the highest fare class and n is the lowest fare class. Like in this case, we have B, M and Y, B, M and Y. So, this will be known as first, this is second, and this is actually N, which is third. So, inventory available booking limit for class I is I let us say is 1. So, booking available for 1 B1 is all the inventories up to Bn. For example, in this case it is B1, B2 and B3. If I talk of I equals to 2, the B2 available for B3 also. So, you can say that if B1 is my total inventory when I am talking of I equals to 1, that means the limits which are available for, if I talk in terms of B, this is B1, this is B2, this is B3. So, in the beginning of this particular allotment process, B1 is equals to 100, B2 is equals to 75 and B3 is equals to 30. So, that is how the total inventory which is available for B is available for Y class. Inventory available for B and M class is available for M class, and for inventory for B class, whatever is available for that is available. So, this is the concept of nesting, and now you can easily understand that this helps us in avoiding the rejection of high fare booking in favor of low fare booking. So, if I see this concept in a graphical manner, so this concept looks like this image. Here you see in this image that you have a different concept also which we will be discussing, that is the concept of protection label. Now, let me talk this is B2, which is the booking limit for class 2, B3 is the booking limit for class 3. Now, here from this particular point to this particular point, this is our total inventory, total capacity of the service system B1. Out of that only these many seats are protected for class 1. Like if I go back to this diagram, this table, B1 is the total number of seats, but out of this total number of seats, 25 seats are protected for class 1. Here you can add y also, it will be confusing, so we will add there only. So, my total seats are like 30, 45 and 25. This is for 3, 2, 1. So, if I talk them in terms of booking limits, in terms of B, sorry, not B, this is B3, that is 3, 30, B2 is 75 and B1 is 100, which is equivalent to total capacity available in the system. That is what we just studied. Now, another concept which we are introducing, that is the protection label. That how many seats, how much capacity is available only for that particular class. So, if I see that 25 seats, if you see this diagram from left to right, you are seeing the booking controls, but when you see this diagram from right to left, you see that how many seats are protected for a particular class. So, first is the protection label which is coming for class 1 and this is Y1, and Y1 is 25 seats are available for category 1. Similarly, if I see for category 2 and category 1, that is Y2, Y2, that how many seats are protected for 1 and 2 together, and 1 and 2 together the total seats which are protected, that you see coming from the right hand side, it will be seats which you can see up to this point. How many seats are? These are total 70 seats which are protected for class 1 and class 2, and then comes Y3, where you see that how many seats are protected for class 1, 2, 3. That means all that actually has no meaning, because total 100 seats are there and all these 100 seats are basically protected for 1, 2, 3. So, practically this has no meaning. Y3 is seats for 1, 2 and 3, and that is basically total capacity equals to 100. Now, if you see the relation between booking control, that is the booking limits for different classes, and the protection label, you are getting a very interesting relation. This is very important relation between protection labels and the booking limits. What relation tells? Yj equals to B1 minus Bj plus 1. For example, if I want to calculate, let us say Y3, Y3 will be B1 minus Bj plus 1, that means Bj is 3 plus 1, 4. Now, in this case you see that B4 is B2, this will come Yj plus 2, because we are talking the protection label for J1 is the first. So, Y1 equals to B1 minus B2, and B1 is 100, B2 is 75, and you directly get Y1 equals to 25. Similarly, if I want to calculate Y2, now Y2 will be B1 minus Bj plus 1, that is B3, that is 100 minus 30, you get Y2 equals to 70. So, in this way, using this mathematical expression itself, you can calculate that how many seats are reserved for a particular class and how many seats are total available up to a particular class. So, this concept of nesting is very interesting, that these many seats you are guaranteeing for this particular class, but otherwise the total inventory available up to that class is also a very good idea. And therefore, if you see this diagram, this B 3 plus Y 2, if you see these two things, B 3 plus Y 2 is the total capacity. Similarly, you see this further diagram, B 2 plus Y 1 is the total capacity. So, you can directly get, and total capacity we know is how much, B 1. So, total capacity can be replaced by B 1 by B 1. So, in this way B 3 plus Y 2 equals to B 1, or we can write B 2 plus Y 1 equals to B 1, because B 1 represents our total capacity, and that is how this particular formula is generated, that whether you are talking of Y 1 equals to B 1 minus B 2 or Y 2 equals to B 1 minus B 3 and so on, you can develop your different particular expressions for this, but the genesis of this formula we just discussed. Going further, we also have a concept which is very important to understand, that is dynamic nested booking control. You can update your booking limits in the dynamic environment. Like you have 5 fare classes in an example, and these are the B 1, B 2, B 3, B 4, B 5, the booking limits. Now, with this you can easily understand that the total seats available in this flight are 100, B 1 is 100. Now, this flight is currently not accepting any booking for class 5, B 5 is 0. So, no booking for class 5. Any booking class with a limit of 0 is said to be closed, that is in general you can understand. We can derive the corresponding protection labels Y 1, Y 2, Y 3, Y 4, Y 5 like this. Like you can use this expression again, that how B 3 plus Y 2 equals to Y 1, or you can say Y 1 equals to B 1 minus B 2. So, Y 1 equals to B 1 minus B 2, or Y 2 equals to B 1 minus B 3. Similarly, you can develop Y 3 equals to B 1 minus B 4, Y 4 equals to B 1 minus B 5. So, in this way you can develop the protection labels for all the, and you can just check that whether the protection labels given here are matching with this calculations or not. For example, B 1 is 100 minus B 2, that is 73, that comes out to be 27. So, Y 1 is 27, 100 minus B 3, B 3 is 12, that is 88, that is Y 2, 100 minus B 4, that is 4, that is 96, Y 3, Y 4, 100 minus B 5 is 0, is 100, and Y 5 is the total capacity, that is equals to 100. So, you can see that how we can calculate the, as our booking limits are changing, our corresponding protection labels will also change accordingly. Now, you have this simple diagram, a table which helps you about the booking limits and the protection label, and then what type of booking control system is happening with this dynamics of booking limits and protection labels. So, here the initial booking limits are given to us 100, 73, 12, 40. As we know that we are not accepting any booking in the class 5, and accordingly initial protection labels are given to you. We just calculated 27, 88, 96, 100, 100. So, 27, 88, 96, 100, 100, these are the protection labels. Now, you see that I will only explain one or two rows in this case, and then we will not explain. And since this slide will be available to you as part of our homework, let us say I request you to develop these rows on your own based on the requests which are coming in this part. So, these are the requests. I have this request to all of you that please do not see, do on your own, and by doing on your own you will be able to develop this table also and this table also. So, you have to use these request, and now continuously you have to decide whether you are going to accept or reject these requests, and you have to dynamically update the booking limits and the production label. Let us see how things are happening. For first 3 rows at least I will demonstrate you. Now, there is a request coming for 2 seats in class 5. Now, 2 seats in class 5 booking limit is 0. So, I am not accepting any request in class 5, I will reject this particular request, and therefore, there is no change in this particular case. 100, 73, 12, 40, 27, 88, 96, 100 remains as it is. The second request comes 5 seats in class 2. Now, class 2 has 73 seats. The booking limit which is available at class 2 is 73. So, I will book 5 seats, therefore, I will accept this request, and as a result of that I will book 5 seats in the class 2, and therefore, the inventory of all the classes will reduce by 5 seats. But since this column 5 has no meaning at the moment, the seats from this will be reduced by 5, 5, 5 everywhere. So, out of first also 5 seats are reduced, because now the total inventory available in the system are 95. 5 seats are given to class 2. 73 out of that also 5 seats are given, 68 seats will be total available booking limit for class 2 now. Out of class 3 also 5 seats are given to somebody, total 7 seats are remaining, and in class 4, 4 seats were available in the beginning. So, only 0 seats are remaining, because 5 is lost, 5 is already booked. Now, let us see the protection label, because this may look slightly confusing. So, you see that in the protection label we use the same formula y1 equals to b1 minus b2, and without applying too much of thought you can use this formula that y1 equals to b1 minus b2, y2 equals to b1 minus b3, y3 equals to b1 minus b4, and y4 equals to b1 minus b5. And using this concept you see that y1 equals to b1 95 minus 68, that is 27 seats are still protected for class number 1, because you are booking in class 2. So, the overall inventory has reduced for 5 seats, from 100 it became 95, but it is not affecting the quota which is available, the protected seats which are exclusively for class 1, these are remaining unaffected. Let us see y2. P1 is 95 minus B3, that is 7, that means 88 seats. So, protection label for B2 is 88, protection label for Y3, that is 95 minus B4, that is 0, 95, and similarly 95 minus 0 is 95. So, you see that you got these new labels 95, 95, 95. So, what it means that earlier you had the protection of 96 seats for class 3. Now, you have only 95 seats protected for class 3, which are exclusively available up to class 1, 2, 3, and you have only 95 seats for class 4 up to class 4 and total 95 seats up to class 5 also. In fact, class 5 has no meaning at the moment because you are not accepting any seat in that, but earlier up to class 4 you were having 100 seats available, but now up to class 4 you have only 95 seats available. For up to class 3 you were having earlier 96 seats available, but now you have only 95 seats available. But you are still having, the interesting thing is you still have 88 seats available for class 1 and class 2. Class 1 and class 2 you still have 88 seats available, and therefore, you can understand that where you are reducing your inventory. You are now have reducing 5 seats overall up to stage 4, and you are reducing 1 seat up to stage 3. So, that is the meaning of dynamic booking limits and protection labels, because with every new request coming, your booking limits are also changing and your protection labels are also changing. But when you will do this completion, you will see that how you are getting the request for other categories, other classes, and these other classes are not affecting, though the overall booking limit is changing as you are getting bookings in different classes. So, the total seats are reducing. So, therefore, booking limits are reducing, but the protection label, the seats which are available for class 1 are not being affected, all these are remaining 27, 27, 27. So, this is a very interesting concept which ensures that you have always inventory available for higher class, and whenever a booking request come for higher class, it cannot be rejected in favor of a lower class when you follow the concept of nested systems of booking control, and you have to dynamically update your booking limits. You can understand that this type of system is very easy to implement when you use computer algorithms. So, these days you have requests coming online, and when you are coming online request, the booking limits are automatically updated, protection levels are also always updated, and based on the booking limits you will decide that whether you are accepting and rejecting. So, all these tables which you are seeing on your screen can be very easily automated with the help of computer programming. So, with this we come to end of this particular session, and we will be talking about one important concept of cancellation that we will complete in our next class. Thank you very much.